Good day guys, in this video we'll be doing a monohybrid cross of sex-linked disorders. Question 1. Hemophilia is a sex-linked disorder that causes excessive bleeding due to a lack of the blood clotting protein. The recessive allele responsible for this disorder is represented by X small letter h. Number 1. Show by means of a genetic cross the possible genotypes and phenotypes of the parents and children if a man suffering from hemophilia and a woman who is a carrier of this disorder decide to have children. I'll start by writing P1, and next to P1 I will write phenotype. The phenotype is a hemophilic male crossing with a normal female. Under the phenotype, I'll write the genotype. The genotype for a hemophilic male is X, small letter h, and a Y. Crossing with a normal female, but she is a carrier. The genotype of the female is X, capital letter H, and another X, small letter h. The hemophilic male and the normal female will then undergo meiosis to form gametes. And once the gametes are formed, fertilization will occur, and we now have the genotype and phenotype of the resulting offspring. The phenotype is 1 hemophilic female, 1 normal female, 1 hemophilic male, and 1 normal male. We are done with number 1. We can now move to number 2. Explain why this disorder affects mainly males in a family. This disorder affects mainly males in the family because they inherit one X chromosome from their mother and one Y chromosome from their father, and the Y chromosome has no dominant allele to mask off the effect of the recessive allele. Moving to question 2. Study the genotypes and phenotypes below that show how the alleles for color blindness are inherited. X and Y represent sex chromosomes. Carriers do not suffer from color blindness but can pass the allele for color blindness on to their children. Name of the person, Sarah. Genotype of Sarah is X capital letter B, X capital letter B. Phenotype is female with normal sight. After Sarah we have Beauty. Genotype of Beauty is X capital letter B, X small letter b. Phenotype is carrier female. Under Beauty we have Leonie. Genotype of Leonie is X small letter b, X small letter b. Phenotype of Leonie is colorblind female. Under Leonie we have Paul. Genotype of Paul is X capital letter B and a Y. Y carries no allele for the disorder. Phenotype of Paul is male with normal sight. Under Paul we have Sam. Genotype of Sam is X small letter b and a Y. Phenotype of Sam is colorblind male. Now that we have studied the genotypes and phenotypes of the individuals, we can now answer the questions. 2.1. Is color blindness caused by a dominant or recessive allele? Judging by what we were given in this table, we can tell that color blindness is caused by a recessive allele. 2.2. Explain why Sam is colorblind even though he carries only one allele for color blindness. This is because the males have only one X chromosome, and the X chromosome is the one that carries the allele for the disorder, whereas the Y chromosome has no alleles.